When Alice needs to verify a message signed by Bob, she will use Bob's public key to verify the signature. However, Alice needs to be sure that the public key she is using to verify the signature is actually Bob's public key. There should be a mechanism proving to Alice that she is in fact using Bob's public key. This mechanism is the public key certificate. A public key certificate is like an ID card, cryptographically binding an individual to a public key. Public key certificates are delivered by certification authorities belonging to a public key infrastructure. In this video, I will present the concept of public key certificate and the public key infrastructures. In a previous video, I presented the digital signature, and this slide is from this previous video. To verify the signed message sent by Bob, Alice uses Bob's public key. But how can Alice be sure that the public key she is using to verify the message is actually Bob's public key? Similarly, in another video, I presented asymmetric encryption. And I mentioned that one conceptual problem of asymmetric encryption is how can Bob be sure that the public key he is using for encrypting the message to Alice is actually Alice's public key. I summarize here the two problems that are in fact the same problem. How to be sure of the identity of the owner of a public key. In fact, to be sure of the identity of the owner of a public key, we need a solution to cryptographically bind an entity to its public key. A public key certificate is an electronic document used to cryptographically bind an entity, called the subject, to a public key. The subject can be a person, an organization, or a web server. Certificates are delivered and digitally signed by certification authorities. A certification authority is a trusted third party authorized to issue certificates. A certificate contains the identity of the subject and the public key. And the fact that the certificate is digitally signed by the certification authority cryptographically binds the subject to the public key. This figure represents Alice's certificate. The certificate contains data identifying Alice: name, address, email, telephone, and so on. The certificate contains also Alice's public key. The certification authority signs Alice's identification data and Alice's public key, and the signature is appended to the certificate. So a certificate is nothing less than a kind of ID card whose content is cryptographically attested by a certification authority. A subject who needs a certificate must send a certification request to a certification authority. And the certificate request should include the subject's public key and the subject's identification data. In this animation, I will show how Alice can request the creation of a certificate for herself. So first, Alice generates a pair of keys, a private key and a public key. Then, Alice issues a certification request to a certification authority, and she joins her public key to the request. The certification authority is a trusted third party authorized to issue certificates. It issues Alice's certificate, digitally signs it, and sends it to Alice. And for your information, the certificate is structured according to the X509 standard. In addition, communication between Alice and the certification authority is done via the Certificate Management Protocol, which is an Internet protocol used for obtaining X509 certificates. Verifying a certificate means verifying that the signature of the certificate is valid. If the signature is valid, and if the entity examining the certificate trusts the issuer, then it can use the public key extracted from the certificate. If Bob trusts the issuer of Alice's certificate, and if the signature of the certificate is valid, then Bob can use Alice's public key contained in the certificate and be confident that he is actually using Alice's public key. Let us describe the verification process of a certificate. In this animation, Bob wants to verify Alice's certificate. First, Bob verifies the signature of the certificate. He computes the fingerprint of the certificate's content. Bob uses the public key of the certification authority to verify the signature. If the two fingerprints are identical, it means that the signature is valid. However, the verification process is not complete. Bob must now ensure that the public key used to verify the signature is actually the certification authority's public key. So Bob must now verify the certificate of the certification authority itself. But to verify that certificate, Bob needs the public key of the authority that signed that certificate. But who signed that certificate? In fact, certificates are delivered by a hierarchy of certification authorities, and this hierarchy defines a chain of trust. At the top of a chain, there is a specific certification authority which is called a root certificate authority. A root certification authority is a certification authority that everybody trusts. This root certification authority has a certificate. But since everybody trusts that root certification authority, it is admitted that this root certification authority can self-sign its certificate. This root certification authority delivers certificates to intermediate certification authorities. And the intermediate certification authority trusts the root certificate authority simply because it is a trusted third party. The intermediate certification authority delivers certificates to end entities like Alice. What is important to understand is that Alice trusts the intermediate certification authority only because the certificate of this intermediate certification authority was signed by the trusted root certificate authority. If it were not the case, Alice wouldn't trust that intermediate certification authority. Let us go back now to the verification of Alice's certificate. To fully verify Alice's certificate, Bob must first verify the digital signature appended to Alice's certificate using the certificate authority's public key. Then Bob must verify the digital signature appended to the certification authority's certificate using the root authority's public key. Then Bob must verify the digital signature appended to the root authority's certificate using the root authority's public key, since this certificate was self-signed by the root authority. This successive verification of digital signatures follows the so-called certificate path. This certification path validation algorithm is the algorithm which verifies that a given certificate path is valid. It is an algorithm that will perform all the steps that I described in the previous slide. That is, a path starts with the subject certificate and proceeds through one or more intermediate certificates up to a trusted root certificate, as I showed you on the previous slide. There are approximately 200 root certificates trusted in modern browsers and operating systems. And this infrastructure of hierarchically organized certification authorities is called a public key infrastructure, PKI. So it's possible to implement a private PKI in a corporate network for internal purposes. But in general, when people refer to a PKI, they refer to the Internet PKI. Let me mention that there is an alternative to PKI, which is the Web of Trust, where users validate each other's certificate. I will not describe this scheme. There are various types of certificates. The most common ones are the SSL TLS certificates. In these certificates, the subject is identified by a domain. And these certificates are intended for the authentication of web servers using HTTPS, that is HTTP over SSL TLS. Client certificates are more rarely used. Subject is identified by any kind of identification data like email, name, address, and so on. And these certificates are intended for the authentication of individuals or sometimes computers. Code signing certificates are important. Subject is identified by an organization name and or a domain name. These certificates are intended for the authentication of software publishers. Software or software updates can be signed by the publisher, and the certificate allows the verifier to authenticate the software publisher. Certificates of certification authorities are generally delivered by trusted root certification authorities. The subject is identified by the certification authority's name. These certificates are intended for the authentication of a certification authority. Digital world is a moving world. Domain name may change ownership, companies may disappear. So a certificate cannot be valid forever. Just like an ID card or a credit card, certificates have an expiration date. If you connect to a web server with an expired certificate, the browser will display a warning. It is also possible to revoke an unexpired certificate. And the most common reason for certificate revocation is when the private key associated with the public key contained in the certificate is lost or compromised. Certification authorities maintain a list of certificates that they have revoked. When verifying a certificate, the certification path validation algorithm must consult certification revocation lists. This figure shows a snapshot of the SSL TLS certificate of my university web server displayed by my browser. So here is the subject's name. It is a domain name. Here's the certification authorities that delivered the certificate, Tirina SSL. Here is the root certification authority that delivered the certificate authenticating Tirina SSL as a certification authority. Here is the expiration date, 7th of March 2022. Validity period of this certificate is 2 years. And here is the public key of my university's website. It is an RSA key of 2048 bits. I could not figure out how to display the digital signature of this certificate from my browser, so I had to dump the certificate and then I could display its signature by using OpenSSL. This signature was created by encrypting with RSA the SHA-256 fingerprint of the certificate's content. Certification authority Tirina SSL used its private key to sign the certificate. This video was about the public key certificate and the public key infrastructure. The public key certificate is the solution used on the internet to authenticate web servers. One thing I did not mention is that these certificates have a cost. The price of an SSL TLS certificate ranges from a few euros per year to a few hundred euros per year, depending on the options. At the heart of the security of the public key infrastructure are these trusted root certification authorities. To be recognized as International Root Certification Authority, an organization must contact leading developers of operating systems and web browsers to be included in their list of trusted root certificates. Of course, application to become a trusted root certification authority involved several steps, both technical and non-technical.